A quant researcher stares at a backtest promising a Sharpe ratio of 3.2. 6 months later, the live strategy is bleeding capital. The culprit? Not a flawed model, a subtle data leak that crept through the pipeline. In AI-driven quantitative finance, the graveyard is full of brilliant algorithms that never survived the transition from paper to production. The truth is relentless: your equity curve only trusts the weakest link in your chain. This is the 7-layer roadmap that turns an idea into a real, risk-managed strategy, insisting that every link from problem definition to risk governance holds firm. Most doomed projects begin with the wrong question: can AI trade stocks? That question is too big to test, you can never prove it wrong. Professional quant shops shrink the task until it becomes a concrete prediction. Target: what asset? Horizon: how many days ahead? Universe: which stocks? Under what liquidity and capacity constraints? For example, instead of asking for a magic black box, ask this: in a liquid equity pool, can earnings call sentiment improve 5-day cross-sectional return rankings? Falsifiability is your first risk filter. If you cannot define what failure looks like, a benchmark, a hurdle, a formal null hypothesis, you are not building a strategy, you are chasing noise. Data is not just about having it, it is about what was truly known at the historical moment. Point-in-time data is the foundation of honest backtesting. If you use a revised earnings number released a month later, you have injected future information. The model will learn patterns that never existed for a real trader. Data lineage, knowing exactly how every number was computed and when it was last changed, separates a production system from a student project. Survivorship bias, delisted stocks, and corporate actions must be handled with rigor. Without this layer, a brilliant deep learning model simply overfits your data cleaning errors more efficiently. You are paying a complexity tax for contaminated inputs. This is where large language models and agent frameworks finally earn their keep. They can parse earnings call SEC filings, and sell-side research, decompose a macro theme into structured factors, and even propose candidate signals with draft code. But their output is only the entrance to the funnel, a raw, untested hypothesis. An agent's conviction is not a position size. An auto-generated formula is not an alpha factor until it passes rigorous out-of-sample checks. Treat this layer as a hypothesis generator that amplifies your research bandwidth, not as a replacement for skepticism. The funnel must be as wide as possible to capture diverse ideas, but what passes through must survive every subsequent screen. Once candidates enter the research environment, they must be evaluated with surgical consistency. Decide upfront: are we forecasting absolute returns or relative returns? Will we use a cross-sectional or time series framework? What is the official metric: information coefficient, R-squared, classification accuracy, or portfolio level Sharpe? Always neutralize sector, size, and style effects, otherwise, you are just paying for factor exposures you could get for free with an ETF. The greatest value of a research platform is not the sheer number of models, but that every idea is forced under the same microscope. A simple linear model that generalizes consistently beats a transformer that overfits to a handful of regimes. Complexity only pays its rent when it captures genuinely new information out of sample. This identity governs the research layer. It reveals why you do not need a crystal ball: a small edge, broadcast widely, compounds into a robust process. A strategy with an IC of 0.03, barely above chance, can deliver an IR of 1.0 if it makes 1,000 independent bets a year. The formula frames the fundamental trade-off: chasing a marginally higher IC often invites fragility, while expanding breadth through diversified signals and universes builds resilience. Complexity is not the hero, breadth is. This lens forces you to justify every additional feature in terms of its contribution to the independent bets count, not to in-sample fit. Validation is the watershed where most demo projects drown. Train, validation, and test sets must be firewalled in time. The moment you look at the test set, it loses its virginity and becomes another layer of in-sample optimization. Walk-forward analysis, which re-estimates the model periodically using only past data, mimics real-time deployment and exposes parameter instability. Stress test across market regimes: How does the strategy behave in 2020 style volatility, or during a slow-motion sector rotation? Vary cost assumptions, stock universe slices, and seed parameters. Here is the mindset shift: you are not trying to prove the strategy works, you are trying to break it. A professional quant is a relentless falsificationist. If the strategy only survives in a narrow window with a specific set of microcap stocks and no trading costs, it is fragile evidence, not a durable edge. Most models do not fail suddenly, their tiny edge is simply erased by friction. This formula lays bare the arithmetic: a signal generating 50 basis points of monthly alpha is worthless if transaction costs consume 60 basis points. Slippage and market impact are not theoretical footnotes, they are the difference between a strategy that looks beautiful in a notebook and one that can survive an actual order book. The analysis forces you to model liquidity, capacity, and turnover constraints before a single dollar is deployed. If you have never run a transaction cost analysis, you have not yet built a tradable strategy. Position sizing is where risk governance meets capital allocation. The Kelly Criterion, though idealized, provides a proportionality principle: when you have an edge, bet more; when the edge is uncertain, bet less. It connects signal conviction to dollars at risk. But Kelly is ruthless about estimation errors: if you overestimate your edge, you overbet and invite ruin. That is why disciplined quants implement a fractional version and overlay hard concentration limits. The formula does not prescribe an exact number, it prescribes a mindset: every bet is sized not by confidence, but by the measured, net of cost edge and the risk capacity of the portfolio. Risk management is not the disclaimer at the end of a pitch deck, it is embedded in every layer. Define automatic circuit breakers for when data feeds go stale or model drift exceeds a preset threshold. Set hard limits per position, per sector, and for the total portfolio. But the crucial structural rule is separation of powers: the agent that proposes signals must never have the authority to override risk limits. A dedicated risk engine, independent of the portfolio manager, must be able to veto any trade. No single model or person should be allowed to generate, size, execute, and hide a loss. Audit trails, version control, and change logs are your only defense against an opaque breakdown. A system without an independent risk veto is not a strategy, it is a single point of failure. You do not need the full 7-layer stack on day one. A staged approach controls risk while building capability. Phase 1, turn AI into a research assistant, let it read filings, clean data, and generate reports, but never touch live orders. Phase 2, evolve into a signal factory, where AI proposes ideas and your fixed, rigorous pipeline validates them. Phase 3, run a portfolio simulation that combines a few vetted signals under a unified risk model, with real-time paper trading that captures execution delays. Phase 4, deploy a small amount of real capital with strict limits and an immediate kill switch. Throughout this journey, measure 5 vital signs: reproducibility, same data, same result, attribution, where did the P&L come from, falsifiability, what evidence would force you to shut it down, controllability, can you limit loss and restore state, and maintainability, can you safely upgrade? These 5 metrics separate a professional production system from a complex but fragile toy. AI Quant is not a magical algorithm, it is a production system where every layer filters a specific type of risk. Open source projects give you components, data tools, backtesting frameworks, agent libraries, but no single repository covers the entire chain. The real system capability lives in the interfaces, validation scripts, and governance rules between them. The next time you examine any AI quant project, do not ask, can it make money? Ask instead, which layer does it address? Where is the falsifiable evidence? What is the next risk gate it must pass? That shift in questioning turns project hype into durable strategy capability. We will see you in the next analysis. Markets reward discipline, not certainty. If this analysis helped, like the video and subscribe to DeepQuant. Tell us in the comments which market idea we should test next. Evidence beats noise. Control risk before chasing returns.